Hello friends, in this video we will start new topic, that is shear force and moment diagram for a beam. In most of the cases we know values of shear force or bending momentum, and still we cannot determine slope properly. So in order to draw shear force and bending moment diagram accurately and determine slope properly, we have to remember 2 points. First one is slope of shear force diagram equals to intensity of distributed load, and slope of bending moment diagram equals to shear force. You have to remember these 2 points, and for sign convention you have to use this sign convention. Suppose I will show you here. Let this is a beam. Let here is 10 kilonewton and here is 10 kilonewton. If you have to find a shear force at any point, let I will find shear force at this point A. So I have to first draw sectional line which will be very close to A. So I will draw this side. This is a sectional line which is very close to A. Now to find shear force at this point, I have to analyze this side, or either I have to analyze this side. I have to analyze only one side. It is very easy if we analyze this side. So this is left side of sectional line, and upward forces on the left side of sectional line we will take them as positive. So we will write shear force at point A equals to 10 kilonewton, because this is left side of sectional line and its direction is upwards, so this is positive. And if we have to find shear force at point B, so we will draw a sectional line very close to point B. So I will draw here. Now I have to either analyze this side or this side. So it is very easy if we analyze this side. So we will analyze this side and we will write shear force at point B equals to minus 10 kilonewton, because this is on the right side of sectional line and it is direction is upwards. So this is opposite to this sign convention. So we will take this as negative. This is for shear force. And for bending momentum you have to remember this sign convention. If any bending momentum will try to rotate beam in upward direction, you have to take it as positive, and if any bending momentum try to rotate beam in downward direction, we have to take this as negative. Let me take a simple example. Let this a beam and these are two bending momentum. So we will take this bending momentum as positive because it is trying to rotate beam in upward direction, and we will take this one as negative because this is trying to rotate beam in downward direction. So this was a sign convention. Now let me solve this simple example. We have to draw shear force and bending moment diagram for this example. So first we have to find support reactions. So for that I will first draw free body diagram of this beam. This pin support, this is a pin support. So both will give two support reactions, but I will only write one support reaction because in this particular case there is not any horizontal force. So horizontal reaction will be 0. I will write AY, that is vertical reaction, and at point B I will write BY, that is vertical reaction at point B, and in place of this uniformly varying load I will write resultant load of equal magnitude, and it will act on the centroid of this triangle. So I will write its magnitude will be area of this triangle, that is 90, and it will act at the centroid of this triangle, that is 9/3 from this support. So I will write here equivalent load 90 kilonewton and distance is 3 meter. Now I have to find first these two support reactions. So I will make two equations. First equation I will write summation of forces in y direction equals to 0, or summation of vertical forces equals to 0. I will take upward distance as positive, upward forces as positive, and downward as negative. So I can write AY plus BY minus 90 kilonewton equals to 0. So which further implies this will be 90 kilonewton. This is equation first, and equation second we will make this equation summation of momentum at point A equals to 0. So what is momentum at point A? Momentum is force into distance. So I will write momentum at point A. Force is Ay and distance is 0 because it is passing through the point A. So momentum due to this force will be 0, and due to this force it will be minus 90 into distance. This distance is 6 meter. This is negative because this is trying to rotate beam in downward direction, and this one is positive. So we will write plus By into this whole distance. This is 9 meter equals to 0, which further implies By equals to 60 kilonewton. And I will write here By is 60 kilonewton, and I will substitute this value of By in equation. First I will get Ay equals to 90 minus By, that is 90 minus 60, which is 30 kilonewton. So Ay is 30 kilonewton. Now I will write here are two reactions, Ay which is 30 kilonewton, and here is another reaction, that is By, which is equal to 60 kilonewton. Now in order to draw shear force diagram, first I will make equal line which is of 9 meter here, and at point A, first I will find shear force at point A. So I will draw a sectional line just close to point A. Either I have to analyze this side or this side. It is easy if we analyze this side, so we are using this sign convention. This is positive. This is on the left side of this sectional line in upward direction, so it is positive. So here is 30 kilonewton, that this is 30 kilonewton. So at point A this is 30 kilonewton, and at point B, if I find shear force at point B, I will make a sectional line just close to point B. So here is force 60 kilonewton, but this is on the right side of sectional line, and it is downward direction is upward, so this is opposite to that sign convention, so it means this is negative. So it is minus 60 kilonewton, and this is 60 kilonewton here. So this is minus 60 kilonewton. Don't confuse with this 20 kilonewton per meter. This is 20 kilonewton per meter. We are moving very little distance, which is close to 0. So at 0 this will be 0 because this is uniform varying load. In 20 meters, if load will be of this magnitude, it will come 20 kilonewton in 1 meter. So we are not moving 1 meter, we are moving 0. So these are two shear force. Now in order to draw a diagram, first I have to find at any point shear force will be 0. So first I have to find this point where shear force will be 0, then I can draw diagram properly. So let we take a section at a distance x, and let shear force at a distance of x from support A will be 0. We will take shear force 0 at a distance of x from point A. So we will draw a sectional line at a distance of x from support A. So we know shear force at this point is 0, but what is actual shear? But actual shear force is due to this is on left side of sectional line, that is positive 30 kilonewton, minus this is in downward direction on the left side of sectional line due to this uniformly varying load due to this triangle, so it will be negative. I will write minus 1 by 2. Base is x, and altitude, I will take this altitude A, this will be 0. So in order to find x, I have to first to find altitude. So how can we find this altitude? We can find this easily because we can use this rule, similarity between two triangles. If two triangles are similar, their ratio of their corresponding sides is also equal. So this triangle and this whole triangle is similar, so I can write x by this distance 9 equals to, this is altitude A by this side, that is 20, which further implies altitude comes out to be 20 by 9 into x, that is 2.22x. So this is a, so I can write here 1 by 2 x into a is 2.22x equals to, I will take this as on right side will be 30 kilonewton, which further implies x square 1.11 x square equals to 30 kilonewton, which further implies if you solve this, x will come approximately 5.2 meter. So I will move 5.2 meter from the support A, that will be somewhere here, and at 5.2 meter from support A, this shear force is 0. I will write here 0. Shear force is 0. Now I have to draw this shear force diagram. Now I solve all these problems. Now I have to solve only one problem, that is I have to determine slope of this shear force diagram. For that you have to analyze load, because slope of shear force diagram is actually load. What is load? From support A, load is in downward direction, that means load is negative. So I will write load equals to negative from support A, and magnitude of load is increasing. So I will write here magnitude equals to increasing. You can see load is in downward direction from support A, so we write load is negative because we take downward direction as negative, and magnitude is increasing. This is increasing load in downward direction, so I write here magnitude is increasing. But actually what is load? Load is slope of shear force diagram. So I will write here slope of shear force diagram of SFD equals to negative, and magnitude equals to increasing. So I have to draw shear force diagram, but slope of shear force diagram will be negative and magnitude of this slope will be increasing. So how can we draw this? I will show you. First, these are quadrants. If I draw a line here, this will have positive slope, and if I draw a line in second quadrant, it will have negative slope, because slope is tan theta. It will have negative slope if I draw this in second quadrant. So it means our slope shear force diagram have slope negative. So it means our shear force diagram will be in second quadrant. This is first condition which it satisfied that it has negative slope. But second condition is slope is increasing when we move from support A to support B. So this is here, when we move from support A to support B, slope is increasing because magnitude of this negative load is increasing. So slope is increasing. How can we draw this? So if I draw a line here, it has zero slope at this point. I will increase slope, increase slope, increase slope. It means it has increasing slope because here it is less inclined, here it is more inclined, here it is more inclined. If I draw a line that like that, it has constant slope because it is equal inclined. But this is line which has negative slope, but magnitude of slope is increasing because at this point this is somehow like horizontal, so it is inclination is zero, or we can say slope at this point is zero. So slope is increasing, increasing, increasing. So we have to draw a line like that. So I will draw here is very little slope, or we can say zero. So, but this is increasing, increasing, increasing. At this point this is zero, and this is still increasing at this point. So this is shear force diagram. This is of negative slope, and so magnitude of slope is increasing. What is actually slope of shear force diagram? It is load. So load is negative, slope is negative, we draw slope negative, and load is increasing in magnitude, so we draw slope which is increasing in magnitude but negative. Now we have to draw bending moment diagram. So I will draw bending moment diagram for this beam. I will make equal line here. First I will find bending momentum at point A, at point B, and at this point, whether this where this load shear force was 0. So first, when I will find bending momentum at support A, so I will make a sectional line at which is very close to support A. So either I have to analyze this whole side, either I have to analyze this side. So it is easy, we will analyze this side. What is bending momentum? Bending momentum is force into distance. So force is here 30 kilonewton and distance is 0 because it is passing through the same point. So bending momentum will be 0 at this point A. So I will write here 0 bending momentum at point A. And at point B, in order to find bending momentum, I will make sectional line which is very close to point B. So we will analyze this side, it is very easy. So what is bending momentum? Force into distance. Force is 60 kilonewton and distance is 0 because the 60 kilonewton is passing through the same point. So it will be 0. So I write here bending momentum at point B is 0. Now I have to find bending momentum at a distance. This was 5.2 meter approximately, at 5.2 meter. So I will move 5.2 meter. Let this is distance 5.2 meter. So I will find shear force, bending momentum at this point. Either I have to analyze this side or this side. So it is easy if we analyze this side. So what will be the bending momentum? I will write here. We have to find bending momentum at this point. So bending momentum is force into distance. This force is trying to rotate beam in upward direction, so this will be positive. So I will write here bending momentum at distance 5.2 meter will be 30 into this distance. Distance is 5.2 meter, and due to this uniformly varying load, I will write point load instead of this, but which have same equal magnitude. So this will try to rotate beam in downward direction. So I will take this as negative. So this will be the area of this triangle. Magnitude will be area of this triangle. Force due to uniformly varying load, that is 1/2 base is 5.2 into altitude. Altitude is, let me write this as A, into this, into equivalent distance. So equivalent distance is, and this point load will act on the centroid of this triangle. So equivalent distance will be 5.2 divided by 3 from this sectional line. I will write 5.2 divided by 3. So this is the momentum at point which is 5.2 meter from support A. So I have to calculate this. So this will come 156 minus 5.2 minus 4.5A. So I have to find first this A. So I will use again this property of similar to two similar triangles. So 5.2 divided by this whole distance is 90 will be equal to this altitude A divided by this 20, which further implies A will be 20 into 5.2 by 90, which will be 20 into 5.2 divided by, this is 9 divided by 9, so it will be 11.55. So altitude is 11.55. I will use this value here, so I can write 156 minus 4.5 into A is 11.5, so I will multiply 4.5. So this will be 52, which further implies 156 minus 52 is 104. So this is 104, which means at a distance of 5.2 meter from support A, bending momentum will be 104 kilometer meter. So it is here. I will move 5.2 meter here. Bending moment is 104. So I will write here 104 kilonewton meter. Now I find these three values. Now I have to determine slope. So how can we determine slope? This is shear force diagram. So you can write here positive, 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 because this is upper side of this x-axis and this is negative shear force, because this is on the lower side of this x-axis. Now from the support A to point 0, how can you determine slope? From support A to 0, shear force is positive and shear force is decreasing. Positive shear force but decreasing in magnitude. So I will write here shear force equals to positive, magnitude equals to decreasing. So which further implies, what is shear force? Shear force is slope of bending moment diagram. So slope of bending moment diagram equals to positive and slope, magnitude of slope equals to decreasing. So how can we draw this? If this is first quadrant, the slope will be positive in first quadrant. It is confirmed. We have to draw line which lies in first quadrant, and from this point A to point B, magnitude of slope is decreasing. So here will be more slope, here will be less slope. So I will make line this like this, because there is zero slope, then this is increasing. Here is more slope, then this is decreasing, and at this point slope is 0. So I will make line like this. Here is more slope, slope is decreasing, at this point slope is 0. Why will be slope at this point will be 0? Because actually shear force is 0 at this point. So it means, what is shear force? Shear force is slope of bending moment diagram. It means slope of bending moment diagram at this point will be 0, which is shear force at this point. So slope will be at this point 0. Now we have to determine slope from this point. This I will write here point C, from point C to point B. So what is property of shear force? Shear force is negative from point C to B, and shear force magnitude is increasing. So I will write slope of bending moment diagram will be negative, and it will be of increasing magnitude. Magnitude equals to increasing. So it means slope will lie on second quadrant. I will make here, this is second quadrant. Here slope is at this point B. This is slope is increasing in magnitude. So from point B, this is point C, I will make a line which has negative slope, but slope will be increasing. So this has 0 slope here, then this is increasing slope, but in negative direction, increasing slope, because this is more inclined, this is more inclined. So it means it has negative slope. This is in second quadrant, and slope is increasing from point this C to point B. So we'll make a line here like this. So this is a line which has negative slope, so shear force is negative. Actually slope of this bending moment diagram is shear force. So slope is negative, shear force is negative, our slope of bending moment diagram is negative. Magnitude of this shear force diagram is increasing because here is less magnitude, here is more magnitude. Magnitude is increasing, so slope of our bending moment diagram is also increasing. At this point bending momentum is this, at this point slope is 0 because slope is actually, slope of bending moment diagram is shear force. Shear force at this point is 0, so slope of bending moment diagram is 0. Hope you can determine very easily now. When we solve more examples it will clear you. It will take time to learn and you don't have need to remember write all this, you can directly guess. If this video is helpful for you, please like this and subscribe engineering tutorial. Thanks, have a nice day.